Hey, welcome back to Mr. P Helps with Algebra 2. This is Unit 3, Topic 2, SLT7. We are going to be identifying key features of sine and cosine graphs so that in the next video, you can take the equation and graph it, which is kind of the opposite of what we're doing in this time. We're looking at graphs here and seeing what the key features are. All right, so we start off with the warm-up. Cosine of theta is 4 over 5, and it is in quadrant 4, so we know it's down here. So that would be 4 neg. Okay, so cosine is always x over r, so we know that the radius is 5, and we know that this is 4, so we need to know what this is. It's going to be negative something. It's a 3, 4, 5 triangle. I know that because it's always a right triangle. In this case, 3, 4, 5 is the Pythagorean triplet that fits. All right, so sine would be y over r, so that's a negative 3 over 5. Tangent would be y over x, so that's negative 3 over 4. And if I want to find what theta is, keeping in mind that it's in quadrant 4, so when you solve this, you're going to have to still figure out what theta is, which is all of this. So let's find out what that reference angle would be. Sorry, I should have had my calculator up and ready. Sorry for the delay. Here we go. So inverse cosine of, inverse cosine of 4 divided by 5. And that's going to give me about 36.9. I'm going to round that to the nearest tenth. 36.9. And if I'm doing this in the fourth quadrant, then you know it's 360 minus that number. 360 minus 36.9 gives us about 323.1 degrees. Okay, so the center of the wheel is 30 meters above the ground. So here's the Ferris wheel member, this activity. And this graph is going to reflect that. So how does this graph reflect 30 meters? Well, if you find, that's called the midline. It's the center of the graph, the dotted line I have going through the middle. It's called the midline. It's exactly halfway between the top and the bottom. The radius of the wheel is 25 meters. Now, I know that's 25 because the distance from the midline up to the highest point is 25. Or you could say the midline down to the lowest point is also 25. So remember, the midline is in the middle, and the height it is away from both sides, since it's in the middle, is called the amplitude. All right, and the wheel completes one full cycle, so you need to know three things. This is the third thing you need to do to write an equation, is you need to know how many cycles it does per 2 pi amount of time, or per 360 degrees, or in this case, it says the wheel completes one full rotation every 20 seconds, so it goes from here to here to here to here to here. So I know I've done this before. I've labeled it A, B, C, D, and then we can call that E. So if you think about a circle, so if this is position A where it starts, this is position B, this is position C, position D, and this is back to where you began, which is position E. So it takes 4 rotations, 4 90-degree rotations to complete one full circle. And I usually put a dotted line, and there you go. There's 20 seconds. Now, this graph does more than one rotation. So a lot of people, what they do is they'll just look at the end of the graph and say, oh, it takes 40 seconds to complete one rotation. No, that's more than one rotation on the graph. Sometimes they will only give you a half a rotation on the graph. So you really have to understand how long it takes to complete one rotation by looking at the graph and seeing how many 90-degree rotations it did. So this goes A to B to C to D to E. So this is actually 2 full rotations, which makes sense because that's 40 seconds. How does the graph reflect this? Okay, I think I've already described that. Use what you know about circular motion to explain how you would write that equation. Okay, so in this case, we're going to take the amplitude, which was 25. So it's amplitude multiplied by the sine of our midline. Okay, sine of, I'm going to call this D times T. So I get confused based upon what people like to use for this. I'm going to use D for the degrees per second, multiplied by T amount of seconds, and then you add the midline at the end. And there's your formula that we're going to be using. So when you look at this case, you'll see that the plus 3 on the outside is actually the midline changing. which is what I had done before. So the midline is 3. The amplitude is 1, which is the reason why there's a 1 out front. And then the period, how long of time does it take to complete one rotation? It takes 2 pi, so it completes exactly 1 rotation per 2 pi amount of time. For this next question, the midline, where is the middle? So it looks like it's about 10, I think. We'll see here in a second. So that would be 10, 20, 10, 20. Yep, so amplitude is 20 on both sides. Period, 1, 2, 3, 4. So it takes 60 degrees. 60 degrees. Usually I would think of that as time. Whatever. 60 degrees to complete 1 full rotation of the circle. So for this time, so this means it takes it does 2 cycles per 360 degrees. So that would be 1, 2, and that makes sense because that's 2 right there. There's 1 right there. Its amplitude is 5 because that means it's the height away from the midline, and 4 is the actual midline, so I'll draw that there. 5's the distance, 1, 2, 3, 4, 5. So there we go. So that's the distance from the midline. That is the midline, and this is how many cycles it does per 360. So going back to this one, so if it's 60 degrees, that means it does 6 rotations per 360 degrees. So midline, so if I was going to write that as an equation, that would be amplitude times sine of 6, 6x, and then plus the midline, which is 10. There you go. Because it does 6 cycles per rotation. And that's where I'm going to stop it. All right, thanks again for watching, and I'm going to cover everything I have later in this video, actually in the next video, or actually in previous videos I've done that unit circle. If you look at my previous video, you can see how to understand a unit circle. Thanks again for watching. Have a great day.